Hi everyone, welcome to lecture series of computer networks. In these lectures, we will be studying completely about computer networks, how computer networks works and how they are connected, how they communicate between each other. How the computers communicate between each other. These things we will be studying in this lecture series. So today in this particular video, I will talk about how internet works and some more technical details about the working of internet. Suppose that you are standing somewhere here on the planet and you want to browse some YouTube video in your mobile, and that video is stored quite far from your current location in the Google server, which is here, and you want to get this data to your phone. So what is the way to communicate this data to your phone? One way is to do that using a satellite, which means the server can send the data to the satellite and satellite can send the data back to you. This is one way, but this is not the only way. In fact, this is the way that we do not prefer because of this long distance. So generally these distance are in thousands of kilometers. So suppose this distance is let's suppose 40,000 kilometers, and if we use this way, which means if the Google server has to send the data to the satellite and then satellite has to send the data to us, then in this the whole process our delay will be too much, right? There will be too much of latency, which is not desirable. So this satellite way is not preferred. So like satellite is not preferred way due to latency. Then what else we can do? The second thing that we use is this optical fiber, which is a cable wired cable, and almost 99.99% internet uses this optical fiber. Because of optical fibers, the latency is very low. That's why we use the optical fibers. But now you must be wondering that in your phone, when you are browsing your phone, there is no cable that is connected to the phone, right? There is no cable that is connected to the phone. So how this optical fiber comes into the play when you are using your phone? I will answer this question a little later. I will tell you that where is the optical fiber. Optical fiber is not directly connected to your phone, but the wireless communication is only limited, which means we use the wireless communication but not too much. So these optical fibers are spread across all the world, which means under the ocean also there are many optical fibers that are laid on, and we uses these optical fibers. So there are companies which install these optical fibers are called ISPs. So these are the tier 1 ISPs. Tier 1 ISP means these ISPs connect different countries. So in fact there is a website that is submarinecable.com, which will tell you that what is the situation of all optical fibers that are laid under the ocean. So if you look at the India, then there are some landing points. If you see here that Mumbai is one of the landing point. This is Mumbai. Mumbai is one of the landing point where your many optical fibers are connected. Another landing point is Chennai. So this is Chennai, and another landing point is I think like there are a couple of landing points for India. If you want to browse something that is outside India, then first it will go to one of the landing point, and from these landing points is routes the traffic. So this is the situation. In fact, you can see for the many other countries that what is the situation of the optical fibers in the whole world. So if you see there are thousands and millions of optical fibers that are lying under the ocean and which are helping us in daily to daily routine. Now let's come to the question, where are the optical fibers in my mobile? Like my mobile is here, but I do not have optical fibers here, right? So the answer is that we have the wireless communication from the mobile to the nearest cell tower. So this is our cell tower. To the nearest cell tower we have the wireless communication, but from this tower to the tower nearest to the server. So suppose this is the tower which is nearest to the server. So from this tower to this tower, mostly this is wired communication, and then from this tower to the server there may be wireless communication. this communication may be again wireless. So mostly this is wired communication for the long distances, but for the short distance, like from here to here only, I mean from your mobile to the cell tower or from this cell tower to the server, there will be wireless communication. But mostly from tower to tower, this is wired communication only. See here, suppose your YouTube server is here and you are at your home and you want to browse some video. So this video will, like, this data will be communicated through this tower, and this tower and this nearest tower or nearest landing point is connected with the optical fibers. So these are connected with the underwater optical fibers, and this communication may be wireless, which means from here to YouTube server this may be wireless, from here to here this is wireless, but mostly the communication is wired communication only that we use in daily to daily life. Now let's talk about bit more technical details, which means how connections are actually happening. Suppose that you are under this network. This is one of the network under which you are operating, and you want to get access to the data which is under this network. Suppose that you have the laptop which is under this network, and there is one server from which you want to access the data. This is your PC. Now suppose you type google.com, then how you are going to get the data from this server to this PC? This is what we are interested in. Like google.com server is here, Google server is here, and you want to get the web page of Google from this server to this PC, right? When you type google.com, then there is one service called DNS service, which convert this google.com, which is called domain name, to something called as IP address. IP address. Now there might be some IP address of Google which is not our responsibility, which means DNS provides conversion from google.com to the IP address. Suppose the IP address is 113.27. Suppose 39.48, some IP address. Okay, I don't know what IP address is, but which is not our tension, because google.com IP address will be provided by DNS server, right? So whenever we type google.com, this google.com domain name will be converted to something called as IP address. Now in this lecture we will mostly talk about what is an IP address, but before that let me tell you the overall communication, how it is happening. So when you type google.com, then this google.com will get converted to some IP address, which is this, suppose. Then this packet, like the request package, will get through the different routers, and through those routers, once like those routers identify that this is the IP address, so their routers knows that where is the server, right? So there are some routers which will redirect this packet towards the server, and then once this packet reaches to the server, it will reply back with the web page, and the whole information that what it wants to access and everything will be contained in the packet, request packet, and then this is the reply packet. This is how communication is happening. Now how google.com, this server, knows that where to reply? This will be identified by the IP address of this PC. So this PC has one IP address, this server has one IP address. In fact, like every connection has one IP address. So I will talk about this more in the next few slides. So every connection has one IP address, which means if you are connected to the internet, then you will get some IP address, and server is also connected to the internet, so server will also get some IP address. There are two popular notations to represent the IP addresses. One of them is called binary notation, another one is called dotted decimal notation. So IP address is of 32 bits in binary. So these are 32 bits, and the way I have represented these 32 bits is group of 8 bits. So this is 8 bits, this is another 8 bits. Similarly, all are the group of 8 bits. Now this is binary representation, and in binary the total number of bits are 32 bits. So we will talk about IPv6 later, but for now we are talking about IPv4. For IPv4 these are just 32 bits. And if I represent this binary address into decimal address, then there is a special notation that is called dotted decimal notation, which says that instead of converting the whole binary to decimal, what we are going to do, we are first converting, we are going to convert this group of each 8 bits to the decimal. So suppose if I convert this group of 8 bits to the decimal, then this will be 128. Why? Because this bit is 1, which is having weight of 2 power 7. Why? Because there are 7 zeros after this 1, and this bit is having weight of 2 power 6, but the current bit is 0. That's why the total weight will be 0. So if you convert this binary number into decimal number, it will be 128. Similarly, if you convert this binary number into decimal number, it will be 11. Similarly, likewise, we can convert every binary number into decimal number individually. So this notation is called dotted decimal notation. Now again, in binary representation, IPv4 address is 32 bits address, and in dotted decimal, it is represented like that. Now, what is an IP address? Like, till now, you know little bit about the IP address. Like, this is something which is unique, which is an identifier to anything which is connected to internet. But it's not quite true. I mean, it's almost true, but not 100%. What I mean by that is that IP address is not directly assigned to any host. It is basically assigned to a connection, which means suppose there is one device, suppose router, which is connected to two networks and via two connections. So this is one connection which is called interface. So this is one interface, this is another interface. Now since this router is connected to two interfaces, that is why this router will be having two IP addresses. Now suppose you are having some router which is connected to three interfaces. In that case, that router will be having three IP addresses. Actually, each interface has their own IP address. So if there are three interfaces on which the router is connected to, that is like in that case, the router will be having three IP addresses. In fact, each interface has its own IP address. Now generally our laptop gets connected to only one interface. That's why our laptop will be having only one IP address. So IP address is of the connection or the interface, not for the host. Okay. Now IPv4 addresses or IPv6 addresses, any address like IPv4 or IPv6, in general IP addresses are unique addresses in the sense that each address defines one and only one connection to the internet. Which means if you want to uniquely identify your host or any of the device which is connected to internet, like it could be anything, anything, like which means router, host, or anything which is connected to internet, and if you want to uniquely identify this, then you can just give an IP address to that. In fact, it has to have IP address once it gets connected to internet. So if a device has two connections to the internet via two networks, it has two IPv4 addresses. I hope that is clear to everyone. Now I would like to take an analogy when I am defining the hierarchy in the addressing from the postal address. So suppose you want to post something to your friend, then what you need to specify? You need to specify the country name, you need to specify the state name, maybe the city, maybe the street name, and maybe the house number, and also the person to which you are sending the post. So these are the things that you need to specify. So there is a fixed hierarchy, which means first country, then state, then city, then street, then house number, then the person name, right? So like this is the hierarchy when you are sending some post to some of the friend or any person, like using the postal service. Similarly, if you use the telephone service, then also there is a fixed hierarchy, which means there will be a country code, area code, local exchange code, and these things. Now coming to the IP addresses also have some hierarchy, which are divided into prefix and suffix. Now suppose I have 32-bit IP address, right? 32-bit IP address. Now this will also be divided into two parts. One part is called prefix, another part is called suffix. Now this prefix part is also called network ID. So basically there will be a network ID. I am writing NID. N means network, ID means ID, right? And HID, host ID, which means like first you need to tell on which network my host lies on. So suppose there are multiple networks and my host is within this network. So network ID will tell me that this is the network. Okay, network ID will identify the network name, and once the network get identified, now within the network there is a host, right? So to get to this host, you need the host ID. That's how this hierarchy works. So suppose this is your IP address, your prefix is your network ID, which defines the network, and suffix is your host ID, which defines the connection or the host. So this network ID, if you look at this diagram carefully, then this network ID is identifying the network, which means it is up to, the job of this network ID is to reach till this point only, which means till the network only. Now within the network, the host ID will play the role, which means if you want to connect to or you want to identify some of the specific host within the network, then you will be using the host ID. That's how it works. So suppose if I give n bits to the network ID, then there will be obviously 32 minus n bits will be assigned to your host ID. Now suppose the n is 7 or 8. In this case, I have network ID of 8 bits, and host ID of 24 bits, right? Now let me ask you a question. Suppose that n is 8, which means your network ID is again 8 bits and your host ID is 24 bits. Now in this case, if I ask you a question that how many number of networks are possible, number of networks possible in this setup, then what will be your answer? Just think about it. See, we have given 8 bits to the network ID, which means there are 8 bits possible to identify our network. And I am asking how many networks are possible. Or sometimes they may ask you that how many organizations are possible, because one network ID is assigned to one organization. So how many organizations are possible? Now since there are 8 bits that are given to our network ID, that's why there will be 2 power 8 networks are possible, or 2 power 8 organizations are possible. And within one network or within one organization, there will be 2 power 24 hosts are possible. So there will be little less, I mean 2 power 24 minus 2 hosts will be there, because one address is used to like reserved for the broadcasting, and one address is used for network ID. But anyway, like almost 2 power 24 hosts are possible. Or instead of saying host, if I specifically use like how many IP addresses are possible within one organization, then you will say 2 power 24. If I ask you how many hosts are possible, then you will just subtract minus 2. By the way, I will come to that point later, that why we are subtracting minus 2. So here let's not worry about like why we are subtracting minus 2 and like what is the broadcast address or what is the network ID. So basically within this two, one is broadcast address and one is the network ID. That's why I am subtracting 2, and there are not exactly 2 power 24 hosts are possible. That 2 power 24 minus 2 hosts are possible. But let's not worry about this minus 2. Okay. So 2 power 8 networks are possible, and within one network, just listen here carefully, within one network there are 2 power 24 hosts are possible, or you can say IP addresses are possible. I hope you got the point. Now what do you think, like just looking at the setup, what do you think, is this a good idea to give our organization this kind of setup where we say that you can just use 2 power 24 hosts and your host ID is fixed, basically, sorry, your network ID is fixed, which means I set up how many organizations I can set up. I can set up only 256 organizations. So let's suppose I set up 256 organizations, and within one organization there will be 2 power 24 hosts, almost 2 power 24 hosts, right? So do you think like these big organizations exist? Like I have worked at Amazon, so there I think I do not remember exactly, but I think not more than 1 lakhs employees are there. And if I talk about the IP addresses, maybe like let's say there are 10 times more IP addresses, so not more than 10 lakhs. So in practically, like there are very rare chance, in fact I do not know any organization which is having these many hosts. So practically these kind of setups are not feasible, in the sense that if you even if you give these hosts to one organization, then that organization might not be able to use these many hosts. So they will end up using, like they will end up basically wasting some of the hosts, in fact many of the hosts, many of the IP addresses. That's why practically like it is not very much popular. But here we are taking just an example just to show you that what happens if n equal to 8. I hope you got the idea. Let me take another example. Suppose n is 16, which means there are 16 bits possible for your network ID, and similarly there are 16 bits possible for your host ID. Both are having 16 bits. Now in this case, if I ask you how many networks are possible or how many organizations are possible, then what will you answer? How many orgs are possible? Since I am giving 16 bits to identify the network ID or the organization ID, then you will say there will be 2 power 16 organizations are possible. And within one organization, just within one organization, there will be 2 power 16, almost 2 power 16 hosts are possible, right? This is just within one organization. And there will be 2 power 16 organizations are possible. I hope you got the idea about finding number of network ID bits, number of host ID bits, and how many networks are possible. Within one network, how many hosts are possible. That's very easy calculation. Now coming to classifying the IP address. So majorly there are 5 classes: class A, class B, class C, class C and class D. This type of classification is called classful classification, classful addressing of IPv4 addresses, basically classful addressing of IPv4 addresses, which says that we can divide IPv4 address of which is of 32 bits. If you remember it, this IPv4 address is of 32 bits. So it says that you can divide these 32 bits into 5 parts, such that like we are naming each of the classes: class A, class B and class C, class D and class E. Okay, so class A says that if you are having n equal to 8, which means if you are just giving 8 bits to the network ID, then those kind of addresses falls under the class A. If you are giving 16 bits to the host ID or 16 bits to the network ID, then those kind of addresses are falling under class B. If you are giving 24 bits to the network ID or 8 bits to the host ID, then those kind of addresses fall under class C. Now there are special classes called class D and class E, which are not not classified like that, which are a special purpose. So class D is used for the multicasting, that I will tell you later, and class E is reserved for the future use, which means like we have not used these addresses till now. In future, if we need it, then we will be using it. So basically, just to recap it, class A says that if you are giving 8 bits to the network ID, then this kind of IP addresses will fall under the class A. Class B says that if you are giving 16 bits to the network ID, then these kind of addresses falls under class B. Similarly, there is a class C, which says that if you are giving 24 bits to the network ID, then this kind of addresses falls under class C. Now, there is very interesting part about it. Just by looking at first bit or maybe first 3-4 bits of the address, you can tell whether it is belonging to class A, class B, class C or class C. See here, suppose my address is beginning with 0, then you will say this address must belong to class A. So if you remember, there are 32 bits in the IP address, right? There are 32 bits in IP address. Now if the first bit is 0, then this is definitely class A. If the first bit is 10, then this is definitely class B. Similarly, if the first bit is 110, then it is class C. If it is 1110, class D. If it is triple 4 times 1, it is class C. So while looking just 3-4 bits, first 3-4 bits, you can tell in which class it belongs. Now suppose first bit is 0, which means it is class A. Okay, I'm talking about the class A, which means the first bit is 100% 0. Now what about the remaining bits? If you remember, like this is 32 bit, right? This is 32 bit. If you remember, for the class A, initial 8 bits are given to network ID. Now suppose if I just ask you, what are the possible numbers that we can have in the initial 8 bits or the first byte, minimum and maximum range? So what you will say? See, 0 is fixed here. So what can you have as a minimum number? You must have zeros everywhere else, then only you will be having minimum, right? You must have zeros everywhere else. So what will the minimum decimal number for first byte in class A? First byte in class A. If you just look at carefully, see 0 here, everywhere else is 0. That's why the minimum number in the first byte of the class A will be 0. What about the maximum number? Maximum decimal for the first byte in class A. See, 0 is fixed. What else you can do? You can put ones everywhere else, right? Which means what? This is 127, right? Which means you can have 0, you can have first byte may range from 0 to 127. I hope you got the idea. So from 0 to 127 you can range in the class A first byte. Similarly, we can find out what will be the range of first byte in the class B, class C, class C and class D. So why we are interested in knowing the decimal number? Because if you remember that when we are representing our IP address, the most popular representation of the IP address is the dotted decimal form. So what I want to know, by just looking, not just a bit, I just want to look this decimal number, first decimal number, and then I want to decide whether it is class A, class B, class C, class D or class E. That's why I was just interested. Otherwise, it is just coming from the binary representation. Since the binary representation is having 0 in the leftmost bit, that is why you are having 0 to 127 here in the decimal representation, right? Now I will tell you these remaining fields in the next lecture, but I suggest you to just fill these out. Which means if 10 is fixed, then for the first byte only, just look at the first byte only. For the first byte, what will the minimum number, what will the maximum number? Just fill this table and we will talk about this in the next lecture. Okay. Now again, see, for the class A you have 0, for class B you have 10, for class C you have 110, for class D you have 110. Class D is used for multicast. What is multicast? We will talk about it in the future lectures. Class D is used for the multicast. Class E is reserved, which means we have not used it yet and we will use it for the future. In fact, this whole class full addressing is now absolute. Absolute means like now nobody is using it, and there is something called classless addressing, which will be about which we will be talking about in the next lectures. But it is better to know about the class full addressing before knowing about the classless addressing, because it will give you the intuition that how things are working. Now there is one more serious issue about these classes, which is called address depreciation. So it says that, let's suppose if I take the example of class A, it says that in the class A you have 8 bits for network ID and 24 bits for host ID. 8 bits for network ID, 24 bits for the host ID, which means there are only 128 organizations are possible, and within one organization you have 2 power 24 hosts, which is too much, which is actually like this much large number, which is not practical, which means most of the addresses are getting wasted, as I told you earlier. So most of the addresses in class A are getting wasted. No, it's not only about the class A. It also happens for the class B, which means in the class B you have 2 power 16 addresses, right? 2 power 16 hosts within one organization, which is also too large for current practical scenario, which is also extremely large. That is why class B is also not preferable. Now if you go to the class C, in class C it is actually very small. Now if you just read this paragraph I have taken from the Frozen book. It says that class C addresses have a completely different flow in the design, which means number of addresses that can be used in each network is just 256. So if you remember, in the class C I was having 24 bits for the network ID and just 8 bits for the host ID, which means it is saying you can have 256 hosts within one network, which is very small. So if you just read it carefully, it says that Number of addresses that can be used in each network is just 256, which is so small for the most of the companies, and that's why companies are not comfortable using the class C addresses. So what they do, they either end up taking class A or class B, and again for class A and class B this is too much waste of the host addresses. That's why this scheme is absolute, which means nobody is using this scheme in current scenario, and we will be using classless addressing. Now, just to summarize what we have seen till now, we have seen that how internet works, we have seen what is classful addressing, and what we have not seen till now is that nitty-gritty details of the how internet works, which means I have just shown you the overall idea that how internet is working. It is actually working using the optical fibers. So I have shown you the overall idea, but how the communication actually happening in technical terms, we have not talked about it. We have not talked about it in much detail. So in the future lectures, we will be talking about it in more details, like technically how IP addresses are getting recognized, what is IP data frame, what is TCP/IP, and these things. Okay, thank you so much.